the following programme, trainee teacher Emma Bradley is shown a series of chemistry reactions. Emma has come to the National Science Learning Centre in York to learn how to carry out these reactions in the classroom. The demonstrations have been chosen to highlight various aspects of chemistry, such as rates of reaction and energy changes, and they've all been selected to enthuse and inspire your audience. All the reactions have been assessed as safe to carry out in schools by plebes. So don't just show your pupils this video, get hands-on and show them some real-life chemistry.
So what we're doing now is a really nice demonstration with some ammonium dichromate. So what we're going to do is take our ammonium dichromate, and we're just going to use an ethanol soaked splint to help start the reaction off. So this will act as our fuse. We'll put this in the middle. You actually get a really dramatic reaction where you can see the changes. So if you do light our splint,
the reaction is best carried out in a dish to contain the flakes.
so we can start to see the chromium 3 oxide being formed.
Yeah.
The chromic oxide can then be used in the fireflies demonstration.
So this is the catalytic oxidation of ammonia with chromic oxide flakes, and it's a really nice reaction to show how ammonia can be oxidized with oxygen in the air, and it's an exothermic reaction, but you need a catalyst to make it go. Right. So I've got this really nice big flask, and I'm going to put some ammonia, concentrated ammonia solution in the bottom, which I've got right here. And of course, the concentrated ammonia solution, because there's so much ammonia in solution, you get ammonia vapor being released into the air in the flask. That's right. And I just gently warm it up on there, really trying to encourage the ammonia gas.
The vapour really fills the flask.
Yeah, exactly. You don't want to heat it up too much, but just warm it ever so gently to do that. So I do that, and then I put the bung back on, and that's quite important because then I trap as much ammonia in there as I possibly can. Now here's the best bit. So what I do is I take the deflagrating spoon, I hope you can see that, and I've got the chromic oxide flakes on the end there, and then I heat them up in the flame. And you can see some of the flakes just popping off the spoon. This is the trick of this experiment, is these hot flakes, because they're so light, they float around, and you'll see this in a second. And when you think you've got it nice and hot enough, then it's into the flask, and you need to move quite quickly. So here we go, bung off, into the flask.
The flakes glow as chromic oxide catalyzes the reaction of ammonia and oxygen from the air.
This is one of my favourite experiments. It's a colourful exothermic redox reaction. I've got some potassium permanganate, which is my oxidising agent, and some glycerol. What I'm going to do is put the potassium permanganate in a heap on this tin tray, and then I'm going to make a little indentation in the top. So that's where I'm going to pour the glycerol into. So I'm going to pour the glycerol on. It's quite gloopy.
The glycerol should be fresh, or if it is a bit old, warm it to drive out any moisture. There is a time lag for this experiment, but you can use this to build suspense.
Now there we go, it's taken off. That's the steam that you can see coming out.
Oh, look at that flame.
Pink because of
potassium.
Yeah.
So Emma, here we've got a really simple experiment we can do where we're going to reduce this iron oxide. We've got some non-safety matches, some sodium carbonate and some iron oxide. So first we can actually just can see if they are magnetic, and we can see there that these matches aren't magnetic. This sodium carbonate isn't magnetic, and the iron 3 oxide isn't magnetic. Is we take our match, dip it into some water.
The sodium carbonate helps bind the iron to the match head.
And then we're going to do that again and roll it into the iron 3 oxide. So we have this. Now if you could pass those tongs over, just makes it a bit easier to hold the match, because sometimes it can burn along to the end of it. And we're going to put it onto a hot flame until it starts to go quite black. And then we'll put it out and just give it a gentle blow. Now we're going to crush this in a plastic weighing boat. Give it a little crush. Take that off. Now, hopefully, we should have moving particles around.
This is an interesting variation on displacement reactions. So what we've got is some magnesium powder and some silver nitrate crystals. And what we can do is mix the two powders, which we've kept completely separate, and everything is completely bone dry. So if we just tip the powders into their own little weighing board. Okay, and if we just mix them up by rolling them backwards and forwards.
Gentle mixing to avoid friction is vital.
And then if you can tip them and make a nice little heap in the centre of the tile, that's perfect. Okay. Now obviously two solids aren't going to react together, so what we need is a little drop of water to get the reaction going.
Set the tap to drip about once every 5 seconds and place the mixture just after a drop has fallen. Stand well back.
Okay, reaction for you to have a go at. Okay, two elements reacting together to form a compound, so redox reaction. You've got some iodine and some aluminium powder. What we're going to do is mix the two together using the careful rolling them together method.
The aluminium powder needs to be fresh, otherwise it will already be oxidized.
Okay,
As ever, gentle handling is advised to avoid a premature reaction.
And then into the middle of the tin lid with a nice little heap. Great. Now you just need to put a little indentation in the top with the spatula, because you're going to have to add a few drops of water. That's it. And then over to the fume cupboard. Alright. What you need to do now is just put 2 or 3 drops of water into the centre of the powder heap.
Once the water is added, stand back and wait for the action. It may take a minute or so, but there will be plenty of iodine vapour, so turn the fume cupboard on.
Here we go. That's it.
Oh wow.
And off it goes. Right, there's lots of nice exothermic reactions that you can do, but there aren't many exciting endothermic reactions, and this one's quite a spectacular one. We're going to react some barium hydroxide with some ammonium chloride, and we're just going to mix them together in the beaker. Two solids react, and we'll get an endothermic reaction. You'll see a little bit, okay? Now, just check. The temperature in the lab at the moment is a sort of fairly chilly 15 and a bit. Put the barium hydroxide in first.
As soon as you add the ammonium chloride, you need to start stirring. Be aware that ammonia will be given
If
off.
while I start mixing, if you could just squirt a little bit of water on the block. That's it. And now you can see that the two solids have changed into a sort of a slush, a liquid.
Yeah.
Okay, and that's liquid enough now for me to use the temperature probe. So if I start stirring with that now, and we should see the temperature really start to shoot down.
Go down.
The strongly endothermic reaction will freeze the water, allowing you to lift the block. Why not get your audience to lift it for themselves?
So Emma, what we have here is a really nice demonstration that shows the effective particle size and surface area. Now what we've got is an everyday item, and this is coffee whitener. Now what I want you to do is just try and light it with a match. You've got some matches on you. So you can see it's not catching a light. So what we're going to try to do now is see if we can actually catch the light. And what I want you to do now is if you could just light the end of that splint for me.
Okay.
A lit splint is the safest way to do this demo. Safety screens are sensible too.
And I just want to gently shake this over.
Oh,
And you can actually see there's convection currents as well coming up with it because of the heat.
it floats, isn't it? 'Cause
Yeah.
Be careful not to let the flames reach your hand.
Right, combustion of alcohols on a slightly larger scale. What we've got is a polycarbonate plastic bottle, type you get in water fountains. And we've got some propan 2-ol. So the first job is to put the propan 2-ol into the bottle. So I'm going to add the propan 2-ol. Okay, and then if you can just pick the bottle up, give it a really good swish round.
Okay.
It's important to really give the bottle a good rolling to produce as much vapour as possible.
Into the beaker.
Pour out the excess, or you may end up with a fire that melts the bottle.
That's it. That should be fine. And then if you put that back on the mat behind the safety, and I'll move the propan 2-ol well out of the way. So what we've got, propan 2-ol vapour in there, and you're going to ignite the vapour. Now what you need to do is just get the flame just
Over the top.
inside the top and then take a step back.